Good morning. Today is August 6th, Wednesday. I believe it's lesson 7 of our summer course for grade 11 college math. And we are completing quadratic relations. Sorry, we're starting quadratic relations. Today's agenda, we're going to do a minds on, learning goals, success criteria, quadratic relations, some examples, and then you're going to have some time for Q&A. All right, minds on. Which one doesn't belong? A, B, C, or D? Honestly, I really don't know the answer to this. D, but why? Yeah, no, that's what I'm thinking. I'm like, even if I guess, like, you have to explain like why. I think they all belong because they all have quadratics. Oh, you know what? D has an upside down quadratic. The other three have like all up. So maybe that's why. But then there's this. Yeah, I mean, then there's these lines, but I'm like, the lines don't do anything. I don't know. Well, whatever. It's just the mind's on. It just gets you to start thinking. Let's get back on track. So learning goals. What is it? Identify quadratic relations in a variety of forms. Graph the quadratic in vertex form, and then use critical points of a quadratic to answer your questions. Very straightforward stuff. This is all grade 10. So if you've done grade 10 recently, like I remember one of you was saying that you did it in July, as in last month. You should be fresh. But if it's been a while, then don't worry, I'm going to go over it. All right, we're going to identify key features, critical points, and describe the effects of A, H, and K on a graphical parabola in vertex form. All right, what is quadratic? Well, the name quadratic comes from quad, meaning a square. Because a variable gets squared, it is also called a second degree function because of the 2 on the x. Actually, I don't think I knew that. That's pretty cool. Quad means square, and then we're squaring it, so yeah, it makes sense. All right, quadratic equations. To identify a quadratic relation from an equation, we look for an x, squared term. So here we have y equals 3x squared plus 4x minus 1. See the x squared, we're good. Or y equals 4 brackets x plus 1, close bracket, and then the square minus 3. So that square, if you know BEDMAS and whatnot, that square will apply to that x, and it will become x squared. So these are 2 different forms of a quadratic relation. All right, when a quadratic is graphed, it will take the shape of a parabola. A parabola is similar to a large U. It can be right side up or upside down. So you can have a U shape or an upside down U shape. Pretty simple stuff so far. All review. To determine the type of relation represented by a table, we look at the differences. If the first differences are the same, the relation is linear. If the second differences are the same, it is a quadratic relation. So we're going to do some practice. What type of relation is shown below? So we're going to do that bowling situation. So go ahead and see if you can answer it. Let me launch the poll first. The answer is A. Yes, it is linear. A, linear. This is what you guys voted. That's fine. Let's move on. Same question. A, B, or C, what do you think? Okay, and done. Well, for those of you who answered, good job. And all of you got it right. B is the correct answer. It is a quadratic. So, because you see that too, right? All right, what about this? We'll do the same thing. And I think we're going to end the poll now. So here we have A, B, C. Most of you said B. And the answer is B. It is a quadratic. Well done. So a quadratic, remember, it looks like a U shape. And once again, I'm not right now asking you to solve exactly. We're just looking for a general, how it looks like. So now we have another question. And that's, is this linear, quadratic, or neither? So good luck. All right. So this is what you have voted on, A, B, C. Most of you said B. And and one of you said linear. The correct answer is actually neither. This is a trick. Because the question is, does this look like a U shape? Well, kind of, but it's facing the wrong way. Can we have a U shape facing this way? The answer is no. You can only have a right side up U or an upside down U, but you can't have a U that's been rotated. So that was a trick. So the answer to this is neither. This is not linear. It is not quadratic. It is neither. So not bad. Let's continue. Now you might have to do a little bit of math to do this one, so I'll give you some time. But is this linear, quadratic, or neither? Good luck. So most of you have answered by now. So here, let's see what the poll says. Most of you said A, it is linear, and some of you said neither. Let us take a look at the answer here. For this one, I told you had to do a little bit of math. And this is from grade 9 and 10, because you do it in 10 as well. It's called doing first differences. Actually, you know what? Make it a little bit longer. Because I'm writing. It's difficult to write small. So make another column here. That's what you're supposed to do. For first differences. And then the first column is blank. You don't have anything here. And what you're supposed to do is you're supposed to first, very important, take a look to see if your x values are going up or down by the exact same amount. That's the first step. If your x values are going up or down by the exact same amount, in this case they're going up by ones, then you can do the next step. If they are not, then you have to do something else. You have to figure it out. Here you always take the second value, the one on the bottom, and subtract it from the value on top. So it's 2 minus 5. What do we get? 2 minus 5 is not 3. For those of you who think it's 3, please don't. We're in grade 11 now. We know it's negative 3. 2 minus 5 is negative 3. You punch it in your calculator, you'll get negative 3 as well. All right, remember, we always take the value that's here, and then you go up, subtract it from the value that's above it. So minus 1 minus 2, that's minus 3. Here we have minus 4, and we have minus sign, and we have a negative 1. Please, 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 grade 11, guys. This is some basic math. When you subtract a negative value, when you have like a negative, minus 1, or subtract minus 1, it becomes minus 4 plus 1. The two negatives change into a positive, and negative 4 plus 1 is negative 3. And here we have the final one, negative 7 minus 4, which simply is negative 7 plus 4, which is also a negative 3. Hopefully everyone has noticed the pattern that the answer is negative 3, and they're all negative 3. Another way you can take a look at this is just, do some mental math and look at that pattern. Look, it's 5 to 2. I know it's going down by 3. Then 2 to negative 1, if you can do that. If not, do the math. it's also going down by 3. -1 to -4 is also going down by 3, and -4 to -7 is also going down by 3. So these are called first differences. First taught in grade 9. Presumably, if you had a teacher that taught you this, but it's part of the grade 9 curriculum, and then also used in grade 10 as well. So now this is the third time you're doing this in grade 11. So this should not be new to any of you. The answer is, once all the first differences are exactly the same value, the answer is linear. That's how you do this. Now, I'm going to take this moment to tell you something. If the numbers were not the same, what do? Well, it's not linear, that's for sure. But it's possible for it to be quadratic still. And the way to figure that out is to make another column, extend this, and make another column here. But once again, you kind of block out the first one. And just to show you, like, if you were to just copy the table exactly as this, for first differences, you block out the first one. And for second differences, you take out 2 boxes from the top. And then you start by going here, this number, which is -3, and then doing the exact same value and subtracting it. So it's the exact same technique in which you subtract the top number from the bottom number there. So -3 minus -3, and here you can get a special case where it's 0. And you should get 0 because we've already figured out it's linear. So we know it's linear. So if you were to continue doing this, you just get zeros now. Okay. 0 and 0. So it's just -3 minus -3, -3 minus -3, -3 minus -3. So it's not really anything interesting happening because we know the answer is linear. But had this been a quadratic, what you would have is actual numbers and answers that are non-zero. And the answers should be the same value. Same non-zero value. So for example, let's say the numbers were different and the answers were 1, 1, and 1. That would mean that this would be a quadratic example if the second differences were exactly the same. What if the second differences aren't exactly the same? Is that possible? Yes, it is. Let's say if you just had 5, 4, 3, let's say you have a pattern, doesn't really matter. If the numbers aren't the same, it's not a quadratic. And if the first differences aren't the same, it's not linear. If the second differences aren't the same, it's not a quadratic, then it's neither. Those are your only 3 options. First differences, linear. Second differences, quadratic. Neither if it's neither one of those are constant or the same value. That being said, now you have, how to do it, an example. So try your best to do this one now. And I'll make the poll. Okay, so let's see the answer. Some of you said A, some of you said B, none of you said C. So is it quadratic? Let's find out. I'm going to be a little bit quicker this time because I showed you how to do this. And for this one, let's see what's happening here. We know that first differences here. And the second differences are here. Okay, go to mama. All right, here we have -2 minus 0, which is -2, 0 minus 2, which is -2, and we have 6 minus 0, which is 6, and 16 minus 6, which is 10. Now, -2, -2 minus -2 is 0.